Welcome to our Gen AI Q1 capstone project. This is OnePrompted, our project, and we have come up with a solution for prompt engineering models. So, what is OnePrompted? So essentially, we are a middleman in between the user and an LLM, as we want to improve the prompts from the user in an efficient amount of time to actually create how do I want to say this? Create a better response from any LLM and be sophisticated enough to hopefully do this for future and time to come. And for our setup, we have all of these response files that we have, which we will show later. But I want to get right into the technical analysis. So let's skip over some of this stuff and go straight into exactly what we did. So with the better model that we ended up having, we used a shared GPT data set, which essentially was an entire conversation data set based off of actual ChatGPT conversations that was scraped from a website. So now each conversation came in this format, which was essentially messages from human to GPT to human. After that, we had to parse all this data, get all the prompts and the human-only prompts from them, discard prompts that had context because we are aiming to just improve prompts without needing any context from the conversation, and then split it into very high-quality pieces of data. A lot of this was done through pandas, and I'm not going to go too much into it because it doesn't have too much to do with Gen AI, but it is there nonetheless. So now when we're going to talk about our approach with an enhanced model, we can talk about we have all this high quality data and what are we going to do with it? So firstly, to satisfy one of our Gen AI requirements, we needed grounding, which we use for the context versus instruction of this model. So for each output for a prompt improvement, we essentially prompted our base LLM that we tuned with Vertex AI to say, okay, we have context for this that we don't want to change. This is rules or code or something that you want to give to the model. And we have some instruction telling it, okay, you want to debug the model, debug the model and improve that instruction. So we, our humans, separated these manually because the LLM approach didn't work too well. And we're able to allow the context to kind of ground the instruction improvement. And then in doing so, we also generated improved prompts from the knowledge the distillation using a better model to train our base model, essentially. After doing this, we fed this into Vertex AI fine-tuning. As you can see, there's some graphs here about kind of our data set. If you want to check them out in the notebook, you can. But then we moved into evaluation.
So we used a few different ways to analyze this data. The first was a logistics regression model, which is here, and we really didn't get any good findings from this. All we really had were some similar data points between all the models. The next was an LLM-graded rubric for the prompts, and once again, the results didn't show too much, so we had moved over to grading it for the responses as well, which the data is here, where you can see that the V2 model is tied with the base model for the highest in the responses rubric, and the none model is the best in the prompt rubric. As well, you could also see that the regression model really didn't show any clear leader in performance, as they were all pretty even at 50. So we really didn't factor this into our results.
All right, now we're going to skip straight to pairwise, back with Austin here. So first of all, we see the response V2 here has a better, so essentially what pairwise is, first of all, is that you compare each response versus another in a round robin situation. So response V2s were all compared against all the other ones. So as you can see, response V2 and response base, essentially given freedom to improve the model, had the best results. So now we're going to go to the next images showing the prompt lengths. As you see, there's kind of a trend trend here where most of the trends are most of the prompts are short, which but all the V2 and base have versatile approaches. So as we move on to the next one, we see that none has a very high percentage towards the end, which means the high quality prompts perform better. But you see all the other ones had a very consistent evaluation throughout, and the other response V2 had good participation throughout. So that's it looks like that tuning a model and using improving prompts using LLMs works. Thank you.